And here we have Carrie Coolum, Aaron Electron, Iona Insulator, that make the EEE News team.
Hello, and welcome to EEE News.
Electricity Electronics Evening News.
I'm Carrie Coolum.
I'm Electric Aaron.
I'm my own insulator, and I'm kind of a big deal.
Top story today is a crisis in the West. New York is again without power. Completely ridiculous, I agree, because these Americans just do not understand circuits, which is why we need to educate you, the viewers. So, for some background information. We all know that electrons are free to move around in a conductor. Do you all know what that is? It's usually a metal, like aluminium, whereas an insulator, like my co-worker, Iona Insulator, could be a piece of paper. Now, in New York, voltage is vital. Look at what is happening to Times Square. Look. Yes, so voltage is the energy given to each coulomb of charge. Each coulomb of charge. So, we also know that resistance goes up with a supply voltage when and then the current goes down. So, our vital point, series circuits, should not, I repeat, should not be used in a whole city. This means that the sum of potential differences across the components equals the supply as it is shared. This is the detrimental problem that New York City has put themselves into. Parallel circuits should be used. Isn't it obvious? This is when the electrons have a choice, meaning one break in the city's circuit wouldn't have resulted in this.
I'm reporting here in New York for EEE News at the power cut. I'm here with Harold, a local resident. What do you have to say for yourself, Harold?
It's real dark. I can't see anything.
Do you know anything about the circuits that were used in New York?
You say what?
My point proven. Back to the studio.
Back in the studio. Quick, I know. So, I'm finally going to tell you about a couple of things to educate you all. This is a vital formula that you all must know. I, which is current. Q, do you know that one? Coulombs. Charge! Which is in coulombs. Yeah, that's right. T, time. In seconds. Now, the resistance calculated in a series circuit. It's the total. This is in a parallel circuit, basically. And finally, I think, we have another one. This is voltage, current, and resistance. Finally, ladies and gentlemen, a potential divider circuit, which New York City may well consist of. This consists of a number of resistors connected in series to a supply voltage. Carrie Coolum reporting EE News. Oh.
Hello viewers, this is Electric Aaron. This is breaking news, just in. It has been reported that many senior school children in the UK have a huge lack in knowledge of electrical components. The public is claiming this is an outrage. Studies show that students are unable to recognize input and output devices. Children, these are input devices. Microphone, thermocouple, solar cell. And these are output devices. They convert electrical energy into other forms of energy. This is a loudspeaker. This is a filament lamp. And this is a motor. That is all for now.
Thank you. Go.
Here I have a guest on the show, an average 15-year-old student with an extensive lack of transistor knowledge. I'll invite Joanne Foster to the stage. Okay, Joanne, can you tell me what this diagram is representing?
No.
Thank you. Okay, as you can see, this is a very concerning response. This here is a diagram of a circuit. This being the power supply, this being a variable resistor, this being, what's it called? Thermistor! This being a thermistor. Here's the transistor, here the LED, and the resistor that is normally connected in series with the LED. Now time to talk about a more humorous matter. Turd and lurd.
No.
Turd stands for temperature up, resistance down. And that is precisely how this thermistor works. As the temperature rises, the resistance of the thermistor decreases. As the resistance of the thermistor decreases, the voltage decreases. If the voltage is not able to reach a certain point, then the transistor acts as a switch and switches off. The LED, as a result, turns off.
Go.
Hello, I'm going to be talking about transformers.
One more.
Wrong type of transformer. Yes. So, a transformer is used to change the magnitude of an alternating voltage. So that's voltage in AC. Now, you can affect the size my apologies, of the induced voltage by changing the field strength. So that's the strength of the field. The number of turns in a coil, which is how many turns are in a coil of wires. And by the way, there's a field, a magnetic field around the current carrying wires. Oh, and you can also alter the size of the induced voltage by the relative movement of the magnet. So you could get a magnet and like move it, and depending on how fast you move it, it affects the current. Fantastic. Yeah, thank you. Hello, did you know that when there's an electrical current in a component, there's energy transformation? No, I bet you didn't, peasant. So, an example of electrical energy transformation. So, a lamp, there's electrical energy, and it is transformed into heat and light energy. Yes. There's also another example of energy transformation is a heater. So electric energy is turned into heat. That's why it's called a heater. I'm going to now talk about AC and DC. You may think I'm talking about the band. No. It's all to do with electricity, isn't it? Yes. I have a line here. This represents DC because it's
Direct current!
You've got it. Right. So that means it's constant. We appear to have an escaped animal in the studio, but she's gone. Now we have DC, which means it's in a wave. So it's alternating, sorry, AC, so that means it's like alternating, so it's like back and forth. And this is the quoted value about here, just slightly above the line. But even in a component, if it's AC or DC, the quoted value will always stay the same. Isn't that fascinating? I'm now going to talk about the formula P equals IV. So, it's a very versatile formula. You can derive these other formulas from it. So yeah, it's a pretty good formula. Thank you for watching EEE News tonight, and I hope you've learned. Are you okay? I hope you've learned a lot about electricity. This person would like to say thank you.
Goodbye from me, Carrie Coulomb.
Hello. Bye. Goodbye from me, Electric Aaron.
Stay classy, Edinburgh.
When I walk on by, girls be looking like Debbie Fly. I pick to the beat, walking down the street in my new freak, yeah. This is how I roll, animal print pants out control.